Here we are going to write a program in C to find the real root of the equation x cube minus 5x minus 7 equals 0 that lies between 2 and 3 using Regula Falsi method. Before going to Regula Falsi method, let us try to understand intermediate value theorem. If fx is continuous on a closed interval ab and c is any number between fa and fb inclusive, then there is at least one number c in the closed interval such that fx equals to c. Say this is the function y equals to fx and this is x equals to a and this is x equals to b. Y equals to fx, this function is defined on AB and continuous in the closed interval AB. Then, according to intermediate value theorem, there is a point x for which this fx equals to c. Now let's say the corollary of the intermediate value theorem, which is the Bolzano's theorem. If fx is continuous on a closed interval ab and if fa and fb are of opposite signs, then there exists one root in between a and b. So this is the function y equals to fx and this is the point x equals to a and this much is fa and this is the point x equals to b and this much is fb. Here you see fa is greater than 0 and fb is less than 0. So fa multiplied by fb less than 0. So in this case fa and fb are of opposite signs, so there exists a root in between a and b. In this case, fa is greater than 0 and fb is also greater than 0. So there does not exist any root in between a and b. In this case, fa is less than 0, fb is also less than 0. They are of same sign, so there does not exist any root in between a and b. In this case, FA is less than 0 and FB is greater than 0. They are of opposite signs. Therefore, there exists a root in between A and B. Now let us try to understand Regula Falsi method. Say this is the point x equals to A. This is FA, y equals to fx function, and this point is x equals to B, and this much is FB. So this point is A, FA, and this point is B, FB. Now if we join these 2 points, then this straight line cuts x-axis at this point. Say this one is x1. Now we know that joining 2 points x1, y1, x2, y2, the straight line is x minus x1 by x1 minus x2 equal y minus y1 by y1 minus y2. Now let us substitute these values. X minus x1 is A and x1 is A and x2 is B equal y is at this point y is 0 minus y1 is FA and y1 FA minus y2 is FB. Now x equals to this A minus B will go this side and this A will come here. So it is A minus B FA minus FB multiplied by FA. So this is the first iteration, that is x1 equals to this much. This is the statement for the regular falsi method, what we have to incorporate in the programming code. Now let us write the C program for regular falsi method. Let us first include the header files. Now let us define the function. Here f is the name of the function. Float x given in parenthesis. Float x given in parenthesis is the declaration of the formal parameter x, which accepts the float value that is passed at the function call. It just implies that f is a function which takes a parameter of type float and return the value of the type float. Main function starts. Let us declare the variable I and initialize it as 0. Let us declare the float values a, b, e and x. Similarly, let us print and scan for B, and E. Enter the desired accuracy. Now let us apply while do. Let us try to understand taking one number line. Say x equals to a, x equals to b. For x equals to a, functional value is fa. For x equals to b, functional value is fb. Now if fa and fb are of opposite signs, fa and fb are of opposite signs, means less than 0, then there exists a root, say it is x1. Now in the programming code we have written that while fa and fb greater than 0, do for x equals to a minus b minus a by fb minus fa multiplied by fa. Now if fx means fx1 and fa greater than 0, then take b equals to x. So fa and fx1 greater than 0 means there does not exist any root. So the root lies in between x1 and b. That's why the new x will be b. Otherwise, take a equals to x. So let us write the code in C. Do for I equals to I plus 1. While absolute value of fx greater than e, print the required root with the iteration number. Percentile d for I, percentile f for x, Done. Let us save and compile and run. Enter the value of A, that is 2. Enter the value of B, that is 3. Enter the desired accuracy, that is 0.00001. So the value of I is 6 and required root is 2.747347.